Hello everyone, how's it going? This is Jason. I'm back for another coding stream. This is actually the second part of a two-parter, a rare two-parter that we've done, making this Plants vs. Zombie clone. And so I imagine most of you may not have been around for the first one. I'm going to start off by kind of walking through what we've done so far, and then kind of running through the code and how it all works, and maybe adding some comments in here and tidying it up, and that kind of thing. How is everyone doing today? Let me run this and I'll kind of show you what we've got going on. So if you've never played Plants vs Zombies, it's a kind of grid-based tower defense style game. And we've got the very kind of basics of it set up here. We're not really drawing a grid, but you have to trust me that these are our kind of units which are placed down in a grid. There are various types of units in these kind of games. This one is one which just generates an amount of money like every few seconds. So every time this animation plays off, you can see our money going up here. If you played Peas versus these would be equivalent to like the sunflowers, I guess. Then we have a zombie, an enemy kind of gradually moving up. And then once it gets within range, it's going to start attacking this character. Whittling down its HP. We don't see its HP, but you saw it get knocked out there. And basically, if one of these zombies gets to the end of any of your lanes, again, we're not drawing the grid, but there would be kind of conceptually like lanes along here. If it gets to the end of one of those, then the game ends, and right now it just closes the window, because that's the laziest way I could think of to implement a game over. Yeah, so we got some of the very basic kind of logic working. I think I'll whip out the old image editor so we can talk through roughly how this works. Hey, Ramen Frog, thanks very much for the sub, for the follow, sorry. Yeah, so we have this kind of conceptual grid. I can't remember exactly what the number of cells were. But the whole game world is kind of divided up into this grid. And we're allowed to place our units in any one of these grid cells, like 1 unit per cell. So, you know, we had our little money generating dudes kind of standing like this. Kind of money up here. And then we had zombies or enemies, and what happens is they spawn kind of all along the very right hand side of the map. And then they just gradually move forwards. Now, unlike our characters who can only ever stand like slap bang on the middle of a grid, zombies can kind of be in any position. They stay in a particular lane, but they just gradually move along. And right now there's a bit of logic whereby when they get within a certain kind of range of a character, they're considered to be in attack range, and they basically stop moving, and then they start doing their like melee attack, smacking down our guy until their HP gets dropped to 0, and then if there's no character here, then the enemy's allowed to kind of proceed onwards, and that's kind of how it will work. And the way we'll make this interesting is a couple of things which we don't really have implemented yet is having different types of units. So we still this little money generating unit. We also want like melee and ranged attackers. We probably want like heavy armor units. We don't do any damage, who are just like blockers. And then similarly for the zombies, right? Plants vs Zombies has lots of zombie types, but the main things we've got to play around with are like the speed, the HP, and the amount of damage they do. So I think even just varying those would give us some cool combination. Another nice thing we can do is play around with the actual kind of spawning wave logic of these zombies. Right now I just spawn one in for testing purposes. There's a bit of code here which spawns in our money generator heroes at certain grid coordinates. Then we spawn in our walker enemy, and they just kind of make their way through. We also had this ranged attacker type. It functions very similarly, except they can, again, it's not being shown super well visually, but they're actually damaging this guy here. And then once this dude's HP gets dropped to 0, they'll also get taken out. So the very, very basic logic of like units and movement and health and spawning is kind of in there. What we don't have is the things to actually make this a proper game. So, okay, first of all, that's that's an issue. There's some logic, some bug with the logic which causes the enemy to kind of stop in front of a character, so that's something we can hopefully figure out. Yeah, so we're missing the actual like UI, which would allow us to place units ourselves. Right now, we've just sort of hard-coded some in here for testing purposes, and also the logic which will like randomly spawn these enemies and know how many enemies there are on each wave and what enemy types and the rate they should spawn and all that kind of thing. So yeah, two main forks of this to do now. One is, well, first fixing this bug, which makes that enemy walk straight through our ranger. The other one is adding some UI so we can place these units and have them cost money and stuff. And then lastly, like some actual spawning logic. Then if we've got time, maybe we can implement a couple more enemy types. So yeah, let me also just kind of walk through the code, add some comments, and explain what everything's doing. So this setup function is part of this framework called processing we're using, and this is just called once at the very start of the program. We can use it for general like setup stuff. So we're going to load in our image assets. What we don't want is when we spawn something for it to then load the image each time, because that may cause a little hitch or FPS drop or something. So, you know, we know what units we have, we can just preload all of that stuff. There's not too many of them. This creates the actual window we're playing in. What we have here is kind of initializing our containers, which is where our actual heroes and enemies sit. So that's, as I said, they're slightly different. Like heroes, you can only have one in each grid cell. So the way we store those is essentially like a 2D array. So kind of having the rows and columns, which means that we can index into this. So if this is like coordinate 0, 0, and this is 1, 1, then we can index into any one of these cells like this. And if there's a null in there, it means there's no hero. Otherwise, it can contain a reference to our little hero class. Enemies are slightly different because we can have any number of these, but they're like fixed to a lane. What we have is a kind of list of lanes, and then each lane itself contains a list of. It's basically like a list of lists. Hey Goku, thanks very much for the follow. I very much doubt I pronounced your name correctly. Oh, okay. Goku00. That makes more sense. Cool. Yeah, so we basically have a little list for each lane with all of the enemies kind of as entries in that list. And then when an enemy gets added, we just add it onto the end of the list, and if an enemy gets killed, we just kind of wipe out that entry of the list. Yeah, then we just kind of spawn some stuff in for testing purposes. In reality, we're not going to want to do this, because we're going to create some UI which lets us do this kind of dynamically. Then we have the draw function, which is called once per frame. In the processing framework just does that for us automatically. You kind of just have to know that you need to implement a setup and a draw function. I mean, it's in the docs or the getting started guide, if you care to read that. So first we kind of clear the screen to black. And then we update all of our heroes. So we have a kind of nested for loop here to go through this 2D array. We check each cell if there's a hero there, or rather if there's not a hero there, we just skip that cell. If there is, then we update the hero. If the hero gets flagged as dead, then we kind of clear them out of that cell. Then we update all the enemies. So we're using a slightly more advanced pattern here, which is an iterator pattern, if you're not familiar with that. So this outer loop is kind of iterating over each row. Or each lane, if you like. And then we kind of iterate over each enemy in the lane. And what this iterator thing allows us to do, it's kind of a Java specific thing, although other languages may have comparable things you can do, is it allows us to iterate over all the enemies in this list, but also kind of potentially remove some of them as we're looping over it, which can be more awkward to do with a conventional kind of list. Typically it's a no-no to like modify a list or a collection of things as you're kind of looping through everything in that list of things. It can kind of lose track of things. You kind of need to be careful about it. So this iterator thing and this remove function is kind of a convenience thing which will do that for us. So then we actually update the enemy, then we kind of remove dead enemies. This is the check for if the enemy reached the end of the lane. So they got all the way over to the left hand side. Kind of arbitrarily set some cutoff here, not the cleanest way, but it works. And then we just bail out and just close the window and exit. As I said, the cheapest, laziest way to implement the game over, pretty much ever. Then once we've updated everything, we then go and draw everything. The reason we don't draw stuff as we update it is because things may potentially die and be removed during the update. So here we just do a simple kind of loop again over this 2D array, and if there's a hero in there then we draw them, and now we use a real simple loop to go over each enemy and draw them all. And the UI right now is literally just that bit of text which has our amount of money. In future we want our menu of heroes which we can place down, and maybe some indicator of how far through the current wave we are, like how many zombies are left and stuff like that. And then we have the actual functions which will spawn stuff for us. They're fairly self-explanatory. Spawn a hero, and this is kind of a little factory generator thing which will instantiate a different class depending on which hero we care about. So we have this enum which kind of specifies all the potential hero types, and same for enemies, and then we have specific classes which sort of implement these heroes, which I'll get into shortly. The slight difference here in that heroes just take a row or a column, whereas enemies take a row and a specific exposition along that column. I think for right now we'll probably just always spawn stuff like at the end. But, you know, you could have an enemy type which spawns in the middle, it's more disruptive or something like that. Yeah, so we have a money generator hero implemented and this ranged hero. Then we have the kind of walker enemy there. Of course, when we spawn it, we kind of add it into those collections in the right place. Let's take a look at some of the other code here. So we have our enemy kind of base class here. An enemy has a sprite. It has a certain amount of health, and it has an XY position. We just do a little thing here to flip the sprite so they face left, which makes sense as the enemies are all moving to the left. Then when we update something, we just make sure the sprite is located at the same position as the enemy, if that makes sense. So this little convenience function here, this world thing, allows us to take a grid position. It's kind of a convenience function. It takes a grid position and maps that to an actual specific position on the screen based on some little things here, right? Like maybe, you know, this cell starts at a certain offset. You know, if the top left of the screen is here, we kind of need to know where the grid actually starts and like how wide the grid spacing is. So it will kind of map from like this being 0, 0 coordinate on the grid to the actual specific screen location, which is, I don't know, like 100 by 150 or something like that. So that's what that does for us. Cool, there we go. So we had our kind of base enemy class. There's a function here which I believe has a bug in it, which was causing us to like walk straight through that hero, so I will check there. We'll come back to this since I'm going to need to debug this shortly. So that's the sort of generic enemy base class. The only specific enemy we have is the walker enemy. They have a bit of extra information, like how fast they walk. They have a certain amount of health. We kind of initialize all of their available animations here. These numbers are just kind of specifying if I look specifically at one of these sprite sheets for this enemy. You will see that it's on a particular grid, and up here we have the idle animation, and here's a little animation of them getting hurt, and then here's the animation of them doing their attack. So this kind of specifies the coordinates where that animation starts, the size of the frames, and how many frames it is. And then the sprite class actually handles displaying these. So every time the enemy updates, we just move them left a little bit based on their walk speed and based on how much time has passed since the last frame was rendered. And then again, there may be a bug in this logic, but we check if there's a hero in front of me, then I want to attack them. And I should probably also stop moving left. I think that code is in the base enemy thing. Yeah, this is not working properly, so I will fix this anyway. Yes, the basic logic is if I'm not currently attacking and there's something in front of me, then I should just swing and attack it. Otherwise, if I am attacking it and the animation's complete, then I'm going to deal some damage. And if the hero's not dead, then I'm going to attack again straight away. I'm doing something a little janky here, which is using which animation is playing as a way to track the kind of state of the enemy, when really that's a bit backwards, and maybe the state of the enemy, like whether they're attacking or walking, should be held here somewhere, and we should just, the animation should just be like a visual reflection of that. That would kind of be a cleaner organization and separation there, but for right now we're just kind of using the animation to infer which state something's in. Not ideal, but it works. Otherwise, if there's not a hero in front and we're not idle, then just turn ourselves to the idle kind of walking or shuffling animation. That's that enemy. Then we have our heroes, kind of similar. So they have a sprite, they have an amount of health, they have a flag that indicates whether they're dead and whether the death animation has finished playing. And the one of the implementations we have is this money generator. They don't move or anything. They have their own set of animations. If the health is 0, then it plays the death animation, and when it's complete, it flags itself as like being really, really dead. So there's a slight distinction here, right? Which I think I explained in the previous screen. You often get like something can be dead as far as like logic is concerned, like it's got no HP left, but that doesn't necessarily mean it's ready to be cleaned up and removed for the game entirely, because maybe you want to display some particle effect or like some death animation or something. So the health being 0 kind of indicates that it's it's not going to stop enemies moving through it, it's not going to interact with anything. Dead equals true means it's ready to be actually removed from the game entirely because its animation is finished. If it's not dead, then we do this, right? So we keep a little counter, and then when that counter gets over a certain amount, we reset it, we give the player some money, we reset the counter, give the player some money, and then we play this little money generation animation. And this is just to kind of reset us back to idle when that's finished. So that animation is the one where the engineer kind of reaches up triumphantly into the air, which we can see this little guy do if we watch him for a while. So he waits a certain period of time, and then gives us some money and plays the little triumphant animation, and then just goes back to idle. Cool. The last one there is the ranged hero, and they do something very similar. They have this timer as well. But instead of generating money, they play a shooting animation. And what they do is, yeah, it kind of scans through the line, and as soon as it kind of looks for the closest enemy, and if there was one, then it will apply some damage to it just by reaching in and kind of directly affecting its health there. So those are the heroes and enemies. I think the first thing to do now is just to debug that strange thing which was happening, whereby we had an enemy walk straight through a hero. So I'm just going to give it loads of health because I don't want it to die as we're testing stuff out. And let's see what's going on here. In fact, let me put a couple of these in. I noticed it did get blocked on like the first slot, but not the other. So what I'm going to do is see if it kind of depends on the position which one it catches on. So we should see him stop like directly in front of these things, but that didn't seem to be happening properly. Nope, blasting straight through there. I've probably just got a silly error in this logic. All we're really doing is checking that the enemy's in a certain sort of range from something, and if it is, then we snap it back to like that exact point. It just sort of stands there. Okay, you got caught up on this one. So probably some of the logic to do with how we're like accounting for the grid cells in this case. Check that. So the function is here. So what do we do? So we kind of find the closest cell, right? And then we want to check that we should be greater than that position minus 0.9 and less than or equal to that position. So what are we actually doing here? So the position of a cell is like the central point. I guess we're trying to check if the enemy is in this little range here. So this should be like the rounded X position, and this should be like a rounded X minus 0.9, which I think is wrong. It should be like 0.1. So you know what, let's some debugging. Let me switch on debug mode and see what's going on here. Okay, it's maybe a little hard to see. We're on this line here. Our rounded X position is 5, that's fine. Our actual X position is that's strange actually, it's got some weird context going on. So I would have expected to see, in the debugger, I would have expected to see like the members of this thing here, but we're instead seeing the kind of top level stuff, which is kind of odd. Yeah, and then because some crazy amount of time has passed, it's like shot straight through. Yeah, that's wrong. So I'm going to re-enable this debugger. So here is null. So looks to me like it should be colliding with a hero there. I wonder if we're looking at row and column the wrong way around here or something like that. Yes, we're going row column. Where the row is the Y position. Yeah. Let me check for heroes. We have a hero at 1, 3. Okay, yeah. It's supposed to be row column, but we're actually kind of drawing those incorrectly there. So here it should actually be. So the row should be Y, right? Yeah. Yeah. It probably means we're positioning the enemy a bit incorrectly there. Okay, try this again. Okay, that makes more sense. So if we want to have those heroes lined up, they should actually be like this. So now I think we're rendering, basically where we were rendering things in terms of rows versus columns, and where the like internal logic was considering rows and columns was back to front. So now they should get snagged up. Okay. Let's try and smash through our hero there. Nope, looks like the hero survived instead. Okay, how much health did I give them? Quite a lot. Let's drop that down and hopefully fix that. And one other thing actually is I'd probably not want these heroes to shoot unless there's actually an enemy in front of them. So I could probably do something like you know what, let's do this check elsewhere. I'm doing this every frame, which is not strictly necessary, but and then okay, so here's the logic, right? So we're gonna play the death animation. Then we're gonna bail out. We don't want to do any other logic if we're dead. We want to scan for the closest enemy. We then want to kind of shoot periodically. And when the shoot animation's finished, go back to idle, and if there's an enemy, we want to damage it. So we're not going to start playing the shoot animation unless there's an enemy in front of us, and then if we happen to start the animation but then the enemy gets killed by something else in the meantime, obviously we're not going to be able to damage anything, even though we kind of already started the animation, if that makes sense. So, see them blasting at this guy. Again, let's put his health down to something a bit more reasonable. They do loads of damage. Kind of want to have this set up so he's going to smash through a couple of these and then get killed to check all the logic is working. So they're shooting, shooting, shooting. He's presumably taking damage. Yeah, cut through one of our heroes. They die in spectacular fashion. Love these death animations. So cool. Ah. Continue to shoot. Who's going to win here? work out. One more test I think is to give them way less health, to check that our heroes don't keep shooting if there's nothing in front of them. Ooh. Cool. Okay, seems like that logic is more or less in place and working okay, so I will... Okay, there's a couple of things we could work on. We could work on spawning, or we could work on hero placement. If anyone has in the chat has a preference, then I will go with what you suggest. Otherwise, I will pick one of those, semi at random. So hero placement is going to be like a UI thing, so we need to sketch out a bit of a UI design stuff. Enemy spawning is going to be like this wave-based thing, so we need to figure out what the pattern is and how that works exactly. Oh, another thing we could do is show like health bars. That might be kind of nice to see what's going on and how our little guys are doing, since we don't have different alternate versions of them for getting more and more damage like Plants vs Zombies did. Yeah, you know what? Let's... So in order to show a health bar, we probably... we could just use their health as it is. So... let me... Text size, that's going to be way too big. Draw this kind of small. Health. It's going to be... I'm going to borrow the position from the sprite. Um, 30, something like this. Not quite enough. Try 40. Cool. Let's do the same thing for our heroes. And our heroes are actually not centered in our sprite sheet. So I should probably figure out the little offset there, so I know where exactly to... So I know these are like 128 by 128. I'm just looking at these numbers down here. So the actual above their position is like 43. So that's like 20 pixels to the left. So yeah, this is just like hard-coded, which is not ideal. But for some debug numbers, it should work just fine. Yeah, still not high enough. That'll do. Close enough for me. Okay. Now let's get into some enemies spawning. So I think I'm going to define the concept of a wave. And what does a wave have? It probably has a number of enemies of each type, right? Which are going to get spawned in. So let's do that as a map from enemy type to integer. Let's also have a duration in seconds. Make sure map is imported. Oh, okay, that does work. I was going to say a lot of the fancier things in Java, like type inference, you can't do in processing, but that does seem to work. Okay. Duration in seconds, number of enemies for each type. That kind of gives us the main thing we need. Could just give it a name as well, and then let's set things up like this. So I'm going to create a spawner as well, which just wraps up some of this stuff. So it needs a wave, which is currently spawning. It needs elapsed time. It probably also wants number of enemies which it's actually spawned. This is more like number of enemies to spawn versus the number of enemies we've actually spawned. Let's give this an update. What did we call that? Seconds elapsed. So how do we want this to work? So okay, you know what? So I think one way to do this is, there are lots of ways to do this. So we have a duration in seconds, and we could, from that, we could figure out, based on the duration, based on the total number of enemies, how often should we spawn an enemy? And then we could just regularly spawn an enemy according to that frequency. So I think that's a way that we can do this. So I don't really need the elapsed time, I just need and then like this, right? So this spawn interval, time between each spawn, we need to kind of calculate. So let's give this a something like this, and then we can calculate. You know what, we probably need to count up the total number of enemies from this map, right? So let's say we can iterate through all the values in there. Right, so we can say spawn interval seconds is equal to the total duration of the wave divided by the total number of enemies, right? So if it's 100 you know, if it's 200 seconds and there are 100 enemies all told, kind of included in the wave, then it's 2 seconds for each spawn. Should probably also reset this. Okay, then what are we going to do? We're going to say every time we update, we're going to increment our seconds since last spawn, and then right, so what are we saying? We're saying we're going to count up how much time has passed, and then I could just say if that's larger than our interval, then we're going to spawn something, but it's possible that we like really lag and get a really slow frame, and like, let's say we're spawning 10 enemies per second and like a whole second passes, we actually want to spawn several enemies. So what I'm going to do is, while this is larger than our interval, I'm going to decrement it by the interval, and then spawn something, and then this loop. Typically it's only going to run once, probably, depending on our spawn rate, but it will account for cases where we need to spawn more than one enemy on a given frame. Yeah, probably won't happen, but I feel like it's technically a kind of cleaner, more correct way to do this. We just need to spawn something. Let's make something here. It's going to have some logic to it. That's really it. We probably also want something like this. And then what do we do here? So we need to work out from our wave, we know how many enemies of each type to spawn, like in total throughout the wave, but we kind of want to randomly select from that, right? And then we know we're going to keep track here of how many enemies of each type we have spawned. And you know what? We should probably do that. Reset that here, right? And or initialize those counts to 0, maybe in this loop. Seems to make sense. So this would have to change to I hear an excitable dog scrambling up the stairs, so if you hear any weird noises, that's what's going on. So what are we doing? So our wave will contain this thing, which will be a map of enemies to integers, so it might be like walker, 10 walkers, or like 5 shooters, and like fast walker, like 2 of those, I don't know. Or depending what enemy types we have. Then this is going to go through each entry. It's going to count up the absolute total number of enemies in this one variable, and then it's also going to initialize our num enemies spawned to have 0 and so on. Yeah. So now we've counted the number of enemies spawned, so we need to figure out which types of enemy we might spawn, right? So if we've already spawned the requisite number of a certain enemy class, then we shouldn't spawn any more of them. And it might be none, in which case we can set this wave complete to true. So again, I'm going to loop over these, I believe. probably create a list of enemy. Empty list to begin with. And then I'm going to say if the number of actual enemies spawned for this type, actually let's just pull these out into variables. So if the number of enemies spawned for this type is less than the number we should be spawning in total for this type, then we're sort of eligible to spawn it, right? I'm going to say okay. It's possible that there's nothing eligible to be spawned. If this is empty, then I'm just going to set complete to true, and I'm going to bail out. Nothing more to do. Otherwise, we're going to pick one at random. So trying to remember what random functions processing has for us, which you can use. So go on then Google, take my most personal of data. Random. I'm sure this has something which will give us like an integer. Okay, random low to high. T0. Okay, cool. So it'll be equal to okay, a bit messy here. What I'm saying is you want to pick a random number up to between 0 and the number of types that we can spawn. So if there's 3 types, it's going to give us 0, 1, or 2. It actually gives us a float, so we need to convert that to an integer, and then we look up that particular one. Essentially, this is like picking a random type from that list of eligible types. And then we actually want to spawn that. Probably need to pick a row or a lane. Num rows, right? So make sure that's an integer. So then I'm going to say spawn enemy. Actually it should be this one. So the type to spawn. Row. And Okay. Yeah, the autocomplete was kind of confused because I was using the same name here as this essentially global function which I'm trying to call. Although to be fair, I could probably now move this down to out of here, because that doesn't need to be global anymore. I'm just going to say take that code. Okay. Okay, the code seems to mostly compile, not quite. So we need to actually use this, so let's define some waves. Let's also give ourselves a corner. A linked list because I'm going to want to remove stuff from the top of this, so it's very convenient for that. Let's remove this. So any wave. First wave. Duration is going to be, let's call it 60. Let's have it spawn there's only one. Let's have it spawn 10 walkers, so every 6 seconds or so it should spawn a walker, hopefully. Okay. Let's add it to our list of waves. And then we probably want a function which we're going to use in future. Start next wave, maybe, which just says well, if there are no waves left, let's borrow this logic. Let's just say you win and just bail out of the game. Not making a main menu for this. Otherwise I'm going to remove the first wave and I'm going to say, hey spawner, initialize yourself with this wave. And then that should go through. And you know what, I may put a breakpoint here so we can watch that logic happen. Alright, of course, we create the wave, we want to start the wave right when the game starts. Okay. It's not like that. Okay, I was right. It will not let me see the autocomplete and the error hints and stuff are a bit janky in this, to be honest. That's why it's fine for small little projects, but for anything more serious, it's really not ideal. This whole processing tool. I think you can use it from inside a proper like Java IDE. That's not what we're doing right now. Okay, so got the code here. It has indeed. So I don't know if you can see it's highlighted this line. So hang on, why is it highlighted that line? It should be here. Okay, no, it's this line. So it's pulled the first wave out. There it is, W. It has a name. It has this map, which is not very easy to inspect. It has the duration. So now we're going to initialize that. So I'm going to do step into. So it's going to initialize that wave. It's going to start initializing this thing. It's going to go over. Total enemies is now 10. And for that map, it's now populated. Some enemies spawned. The value of 0. Yep. Yeah, what you're seeing, by the way, here is all the internal Java state of like a linked list or a hash map, which is super not useful. And it would be nice if we could just inspect this in a semantic kind of way, but it apparently does not do that. Okay, then it should calculate the spawn interval. We think how many total enemies were there? 10, and it's 60 seconds, so it should be 6 seconds per enemy. And indeed, it has figured that out. Yeah, let's put another breakpoint in here when the first actual spawn happens. Continue. Oh, okay, we're not updating the spawner, are we, from inside our main code? Well, that would probably be why. When you write code, you should probably call it somewhere. And then this will initialize, sets up our spawner. And then at a certain point, enough time has passed. Okay, you can see it's been 6 point something seconds since the last spawn, so this loop should increment that down, so the leftover is still maintained. Could have just reset this to 0, but it would not, we'd lose any little, we'd kind of leak this and the timing would kind of get slightly out of sync. Then we're going to hopefully do the spawn. I think I skipped right over that. Happening. Yeah, okay. Now getting to other bits of code. So that seems to be doing what we want. I'm going to turn off the debugger and just let this run, and we can debug if indeed there are bugs to be debugged. So we're expecting something to spawn every 6 seconds. We get an error. Ah, because they're too far over to the right. So we spawn the enemy like way far off to the right, and there's no like, it's trying to check if there's a hero in that slot, and it's like not even really on the grid. So we kind of need to correct for that. We wait for about 6 seconds, something spawned in, seems good. Another 6 seconds, okay. Things are spawning in, this guy's getting damaged, that's nice. Our tower placement is not ideal because we've got nothing at the top. So the obvious next thing is to allow us to actually place some folks down. Yeah, and we can see these are kind of coming in at regular intervals here, right? Coming into random lanes. And then once a certain number have been spawned, which I think was 10, what's going on with this text rendering? That looks super janky to me. Odd. Oh, you know what? We never increased our little counter here. So when we spawn something, so I don't super like this because I'm technically looking up stuff in the dictionary like more times than I need to, but in practice this is no way going to be any kind of actual issue. Yeah, that's kind of a premature optimization. I could avoid doing this get like multiple times, but it's really a non-issue here. Okay, let's also add a probably like a enemies remaining, right? So which we can kind of decrement here. That'll be nice UI wise to display somewhere. So let's draw tab over in the top right somewhere. Move it left a tad more. Yeah, maybe we'll have more than 100. I need another digit there, I think. Awesome. And then how do we know when a wave is over? Probably do something like this. Where we say, so if you no longer need actually this wave complete thing, because enemies remaining being 0 tells us that already because they're kind of redundant. So if the enemies remaining equals 0, check for enemies which is still alive, right? So iterate over all of these. Enemy loving, enemy living. I suppose we haven't found one yet. So if e dot this is another common pattern, right? Like when you're looking for something, and once you found the first one, you kind of want to stop looking. You often have to, you know, it's here that we find it, right, within this if, and then we break out. But that only breaks out of this lane. We then also kind of need to break out of searching subsequent lanes as well. So it's often patterns you'll see here where you do a break from an inner loop, and then you can kind of break out of an outer loop here. You can also do this with like labels, but that's kind of like go-to, and it can be a bit janky and messy. So if, wow, that's not a word. If there is no enemy living, then we want to start the next wave. Brackets are off here somewhere. Oh. Okay, so let's give ourselves some more heroes who will actually be able to take some of these things out. How many? We had 4. 1, 2, 3. Okay. Just wanted to give myself enough heroes to actually complete this wave. So we can check that logic. Oh, here we go. Shoot. 1 down. Tearing through these enemies. Oh, we won. We return after winning. Okay, that seemed to work. Interestingly, this exit thing did not actually end the program entirely. It probably just flagged it as exiting at the end of this frame or something. So yeah, needed that return to stop hitting subsequent code. I'd kind of assumed this would be like system.exit thing from Java. Apparently not. Okay. That seems to be doing what it needs to do. I'm going to take a very short break and refill my cup here. I'll maybe let this play once more, and I will catch you in a couple of minutes. Sorry, you have to excuse me, my friend's dog has been gallivanting around. They're pretty adorable. What were we doing? Okay, yes. Okay, so we had the basic logic there, right? We had our enemies spawning in, we had 1 wave defined. We should probably try defining a couple more. To check that that transition works okay. Escalation. So normally these games give you time to like build between waves. Like that kind of logic is, I mean, it's relatively easy for us to implement on top of this, but maybe not the most productive use of time on this stream. So we'll just have these waves run straight together, see what happens. I'd also like to draw the grid. I think that would help. And once we get to adding a bit more UI, kind of be necessary, so you know where stuff can be placed, I think. Couple more to spawn in. Boom. Okay, looks like the next wave started. Yeah, and the pace has been upped considerably. Wonder if they will overwhelm us. Probably not. These rangers are killing it right now. Okay, we are chewing through this wave, no problem. I don't know, actually this looks a bit worrying. Maybe this is game over time. Depends how the RNG treats us for the last few. Okay, that's everything spawned. Already gets wiped out. Obvious point, this game needs to be kind of tuned so the rate and health of these things, it actually makes it a decent challenge. Okay, last enemy here. Cool. The final wave. I imagine we'll have less luck chewing through. I think we may be done for on this bottom lane here. Rena's got pretty low health. If one of these gets in contact with her, he's going down. Whoop. Interesting, something weird happened there with her health, like scooting down below 0. Interesting. But no bad gameplay effects, so let's just let that happen. Okay, I think I'm going to add something to the spawner which says something when a wave starts. Just prints the name of the wave. Okay. I mean, ideally this would be in the UI proper, but I'm just going to throw it down in the console here. Starting first wave. Cool. Now we have some semblance of gameplay. We need a way to place these things. So first I think I want to draw the grid. And what is a grid but a series of horizontal and vertical lines? So I feel like all I need to do is iterate from here, draw lines at these locations, and then draw lines at these locations. So we'll do a pass for the vertical ones and a pass for the horizontal ones. So like this. So so we want to get the position of... Okay, so actually the world position of this tile is in the middle. So this is 0, 0. So if we want to draw a line here, it's actually at kind of minus 0.5. So what I think I will do is... Does world plus take in row and then column? Okay, row. So row is going to be... So we need a line from like here to here, right? So this is row... This is row 0 here, so this is row minus 0.5, and this is row 0, 1, 2, 3, 3.5. That's kind of how this is going to work. So... where were we? Grid. So the row is going to be actually this does both, right? So p vector okay, I think that does what we need. So I can just draw a line from something like this. Probably the line color maybe need to be tweaked. It may not be visible. I'm not sure what the default is. It's probably black, right? So let's make this white, or actually maybe just like a grey. Don't want it to be too intrusive. Okay, that seems to be doing what we need. Now we can do the same thing horizontally. Almost the same code. Zero. Right, so that's two num rows. Plus y. So we're going to start from that to that. Basically the same logic, but just flipping x and y and rows and columns. Okay, I think this will do what we need. Nice. So we're kind of seeing the world grid here. Yeah, they're like not super centered in these things. Maybe I could just offset these things a bit. You can see that their foot is kind of like in the central position, which kind of makes sense. That's how the sprites are set up. It depends as well. If we were to have this, if you could imagine this on a 3D view, so we kind of tilted this around, then it would make more sense that their feet are like centered in the middle of the tile. And I had kind of originally intended to make this 3D, but I think for now this will work as it is. So all I need to do now is have a way to spawn stuff, right? To spawn heroes. So maybe I will have draggable little things, so we can just plop things straight in like that. Or maybe I'll have it so you click on a tile and then a little menu pops up. I'm not sure what we like the most. Okay, I kind of like having them dragged from the bottom because then we can show the prices down there as well, like a little store and a deal. Okay. Character listing stuff. So, how do we want to draw these things? So I could use a sprite as well for each of the hero types. Then the placement's kind of off. I kind of want something that's just like cropped to be that thing in particular. So I think I will do that like this. Keep that like an icon. And then I'll also open up the other things. Warrior and Ranger. I haven't actually implemented Warrior as a unit type. The Ranger. Save that down. Same thing for the Warrior, in case we do end up using them. Okay, let's just draw them down. So reload those in. No, we've got a bit of time. Okay, I'm going to implement the Warrior. I think I will do that kind of as a copy of this. Can I do that? No. So let's call it Melee Hero. I'm going to copy this code and just kind of tweak that. Okay, we're going to need to look into this sprite sheet for the numbers of frames for these animations. So idle, some of these are quite long. So this has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 35 frames. We are kind of insane to have such intricate animations in our game, but I don't know. I think it looks pretty sweet. Then we have the attack animation, which is so pretty long. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wait, 7? Not shoot, it's really attack. Then we have the death animation, which is the same as idle, right? It's 20 or 30, whatever that was, 35. There's actually a row in here which we're not using, which is an animation for getting hurt. We can leave that out. Okay. So we should have a range, right? Let's see, has to be pretty close. Okay, I think this may be it, you know. So let's try placing one of these down in our code here. So let's instead make this our, we need to give it a type. Melee, spawning code, make sure that knows how to instantiate it. Boom, I think that should be it. Probably got some crashing bug in here. Yeah, we're not seeing sort of all in that tile. Okay, what's going on? Oh, okay, this is too big. It should be scaled back down to, is that 3x scale? So I want to put this back. No interpolation, we want to keep the pixels crisp. Okay. This is Sprite Warrior. Export. Okay. Okay, we are seeing them. We would speed up a bit, but eventually they're going to get in range and they should hopefully start swinging at each other. Wow. pretty long. If this doesn't work, I'll be slightly annoyed. You know, when you're thinking I should have just stopped this and like upped the speed and restarted it, and it would have taken less time overall. But every second you then wait, become less inclined to kind of restart the whole thing. Okay, the animations are not super aligned well, but that did actually work functionally, so I'm happy with that. We picked a particular animation where they did this big lunge forward, so I think that's okay. Okay, so now I've got our basic hero types defined, and I think this is what we're going to run with for the rest of the game. I'm going to shop. So for hero type, you know what? I can probably just hard code these. Not ideal, but NG image was not a great name. It's really the NG sprite sheet, but these icons are also images. That probably does mean that my warrior thing was like super large. It was still at like 3x scale when I exported that icon, so I'm gonna redo that. Export as icon. Yeah, it's like 230 odd pixels wide, so it's gonna be massive. Okay. Then I'm going to draw the icon at a certain position, which I'll figure out. You know, let me just do this now. I've just print screen this, and I'm going to pull out the relevant positions. So I'll go to the actual window. Let's put the ranger like here. 92 by 690. Should probably the engineer first, because they're like the sunflower equivalent. I feel like that makes sense. But they should be first. Be the cheaper unit as well. So I don't know, how's that? Okay, that seems fine to me. So I can draw prices maybe underneath those. Oh, that's an interesting point. What are the costs for these things? Actually called money generator. Come on, autocomplete. Money generator. Then we had the melee. I don't know what makes sense there. And then we had ranged, which should probably be more expensive. Okay. Done super like this, I'd kind of like to do this a bit more dynamically and have all of these types and prices and a data structure and loop over it, but honestly for a fixed set of things, sometimes it's easier just to fix them in if they really are fixed. Okay. That size is too big. Something weird going on with the font rendering, but I'm kind of just going to leave that. Let's drop this back down a bit. Like the fonts are looking blurry. I'm not sure why that is. Oh, you know what? It's probably because I have a scale thing going on. Okay, cool. Anyway, there are them. I'll not be able to just drag them onto the battlefield, most likely. So we need a bit of state here, so like UI state. So hero type. Not trying anything right now. But we probably want something like you know what, I'm going to factor some of this stuff out because it's kind of atrocious. And also, in this UI stuff, I'm also going to need to know where these things are positioned, so having a function which tells me at least the on-screen position of a hero in the shop is going to be useful there as well. So, shop position for a hero type. I'm just going to say, if you can hear the dog barking outside. So if the type is equal to this, and I'm going to return 690. The hero type is equal to melee 192. If it is equal to ranged, it could be 292. Otherwise, just give up. Okay. So now what I can do is, when rendering the shop, I can do this a bit more cleanly. I can do something like for hero type T in. So since this is an enum, I can just get the values, I believe, like that. Okay. again, this could have probably been organized a bit more cleanly, so I don't have loads of switches all over the place. Like a catalog data structure, which kind of has all of these things, like what's the image, file name, what's the price. All of these things could have been pulled out into something separate, loaded in from a config file or something, but this is okay. Okay. Let's say position for T. Then I'm going to draw the icon at X. Stop. Y. Then I'm going to draw the price for this hero at x minus 20 dot y plus 50. Okay. I feel like this is fine. It's actually kind of more complicated than what I had before, but it's going to make the actual UI interaction a little bit easier. Okay, they're all being drawn just fine. I'm actually going to pull this out to a separate function as well. Again, when I've got all these lookup functions, it should have just been like a spec class for the hero type, which kind of just includes these, but I'm just going to use the same pattern here. Turn G icon. Turn ranger icon. I could have even named these files to match up with these enum constants and then loaded them all in sort of dynamically. Typically I'd probably do something like that. I'd either do that or I'd have like a catalog type data structure which is loaded in from a file which maps all these file names and things together. But this is just fine. No, I can do the same thing for price. Means I can move this thing right here. Don't pollute this thing quite so much. Now what we can also do here is something like if, take the price here, we can grey stuff out is what I'm thinking. So let's say if price is less than money, no. Yeah, so we can afford it in this case, then we can tint the image. Normally just display it normally, otherwise we can sort of grey it out a bit. So tinting it to like a mid-grey, something like that. Cool. See, they're kind of grayed out. They're not actually that grayed out. Make that way less. Nice, that looks better. So now we have our shop. I want to be able to now drag these things on here. Those should not be tinted at this point, so let me reset the tint before I draw anything else. In fact, when I draw a hero, or even in the sprite, when I draw the image, I could reset the tint here. be aware that when you call these functions, these state changes carry over to anything that happens next. You know, it doesn't know that you finished drawing this, and so if the next line of code happens to draw this, or even on the next frame it starts drawing something else, then that tint will carry over unless you reset it specifically. Okay, so this seems to be good. As our money increases, things are now getting non-grayed out in the shop. So let's now handle a bit of the UI interaction. It's getting a bit big. Let's factor out some of this code to another class. So all of this stuff can come away and at least be factored out here. Oh, oh. Since these are all in the shop and have namespace now, by virtue of being members of this class, I'm going to remove those from the names, and now I can just say something like shop.getPrice. Shop.getIcon and so on. Okay. Some fewer lines of code in here now, but probably a good thing. Okay. You know, a load of this stuff could be factored out to other stuff. Tad tidier there. Okay. I'm comfortable with this level of hackiness for a little coding from scratch project. So let's see what we've got now. Oh. Interesting. Okay, so we have our stuff down on the grid. We have our spawning of waves working. Right now these are all just placed by testing code. Our shop is like visually visible, but I can't actually interact with it yet. So I feel like we're one step away from having this work. Or two. I mean, the first one is actually being able to drag stuff from here onto the grid and have it take away from our money. And the last thing is maybe tuning the spawn rates and health and cost of these things so it's somewhat challenging or fun to play. I don't know, maybe that can be an exercise for the viewer, right? Like I'll release all the code, and if people want to play around with tuning this so it's actually fun, then they're more than free to do so. Kind of funny how the animations don't line up, but you get the picture. Okay, awesome. Let's make these things draggable, right? So logically what I want to do is when the mouse is pressed, I want to figure out, are they over an icon, you know, and an icon which they can afford to buy? If so, they're going to kind of pick it up, and then I'm going to put them in a state where we remember which hero they're dragging, and then when the mouse is released, if they're dragging a hero and they've dropped it on a reasonable position, like on a grid cell, then they're going to place it there. Okay. So something like this, right? So again, we're going to loop through each type of hero. Yeah, in fact, we can say if money is less than the price, then we can just skip this one. We can't really pick it up. Let's also create a vector for the mouse position, because I'm going to want to measure the distance between the mouse and an icon, and we can use some built-in features to do that. If I have a vector object representing the mouse position, processing gives us mouse x and mouse y variables, which it sort of maintains for us for free. So I can say, can I do, okay, I can. This to mouse boss. I'm going to say if the distance is greater than, I don't know, 30, a bit arbitrary. Again, we should probably look at the size of the icons to figure that out. Otherwise, we are dragging that thing. And what does it mean if we're dragging something? We need to like attach it to the mouse cursor and actually draw it, right? So what I'm going to do is say if dragged hero is not equal to null, then we're going to draw it under the mouse cursor. So just like this. So hopefully now that allows us to drag these things around. So if I pick something I can't afford, nothing happens here. I click this one. Yeah. So we appear to be dragging this around. That's cool. It's picking up the tint from the last thing in that list, which is not ideal, right? So we should tint it appropriately. In fact, maybe we can have it grayed out when you're not over a tile, but if you are, then we can show it lit up. That would be kind of nice. And you can drop it and place it. Right now, there's no dropping. We start dragging and then that's it. It's just forever attached. I can pick up a new one, but really does me no good. So probably to figure out if we're over a tile, we should figure out, we should give ourselves a function, maybe in here in fact. So we already have this thing which maps from a row to a column to a specific position. We kind of just need to do the inverse, right? So, which is essentially kind of undoing this offset. So I take the x position that's passed in, so I guess maybe the mouse x, for example. I shift it. Actually, let me do this on a diagram. Okay, so if the mouse is here, then we know that it should be considered part of this tile, right? So we kind of need to find, we know these tiles kind of start here, so we sort of need to find its position relative to this grid itself, right? So we know the top left position, or in fact I think the variable in our class is the middle of the top left tile, in fact. So this would be 0, 0. So we offset it relative to this, and then we just kind of divide by the size of these things to determine which tile we're in, right? So this is going to be like, this distance here is going to be close to 1, because it's like one tile. Yeah, we do things like that. So we do offset, and then we divide it by the width. And then that gives us the sort of tile position. And we do exactly the same in the y-axis. Y divided by grid cell height. And then we need to, I guess, round it to the closest thing, right? So, yeah, so let's just round this here. Since we're rounding it, we can just turn this into an integer. I'm going to say if tile x is less than 0 or tile x is less than or equal to number of columns, or tile y is less than 0 or tile y is greater than the number of rows, then it means we're like outside the bounds, right? We're on like cell -1 or like cell 100 or something like that, which is outside of our actual grid. So return null in this case, otherwise I'm going to return this little array. Nicer. I had a bit of, I was going to swear, I had a bit of fuckery with my rows and columns versus x and y's before, so I'm going to make sure I name them very consistently. Yeah, that reads way better now. When we spawn a hero, go row and then column like that. Okay. Let's say row, column. Awesome. So when we're dragging something, it'll be equal to get tile at, right? And then if it's null, meaning it's not a valid grid tile, then I'm going to tint this like kind of grayed out. Otherwise, I'm going to tint it be full brightness, and then hopefully this should let us see like if our placement is good. I can drag this, it's grayed out. It's still grayed out. This is not working. This is not working. It's not working. Okay. Debug time. What's going on here? Throw a breakpoint in here and just debug this. Okay. Some other old breakpoints I don't need anymore. Okay, so we pick this up. Get the x and y, which are the mouse positions. Then the row comes out to 4. The column comes out to -1. That seems good. Okay, this is wrong. So should be greater than or equal to. So that's what's happening there. Yeah, if you're less than 0 or if you're like off the edge, then we know we're out of bounds. Okay, I think that was just a screw up with my little comparison there. Let's grade, it looks good. Grade out. Good. Good. Awesome. Awesome. So now we know we're able to place it. We can now do that logic, right? So when the mouse is released. If we're not dragging anything, then nothing to do here. Otherwise, what if, you know what? Okay, so it may be that since we picked it up, we no longer have enough money to actually buy it, so we should probably check that again. To get the price of the dragged hero, and then if price is greater than our money, then drop the thing and bail out. Then we need to find the tile at this location. World get tile at mouse X and mouse Y. If the tile here is null, then same deal, right? We can't place it here. This is kind of the way you would cancel buying something. You just drop it outside of the grid. Otherwise, we should be able to actually spawn something at the grid. Well, there's another case, right? What if there's already a hero there? So if heroes so this returned us a little array which packs in the row and column in the first two elements, so we're kind of weird looking syntax with all the square brackets. You could factor this out to like something like this. It would look a bit cleaner. So if heroes row is not equal to null, then we're trying to drop it on a hero that already exists. So we should bail out once more. Now finally we checked. Can we still afford the thing we're carrying? Yes. Have we actually tried to drop it onto a legal tile position? Yes. Is there anything already there? No. So I believe at this point we are finally good to actually place the damn thing, and then we can just call our friendly spawn hero function. Hero at row call. Should probably stop dragging at that point. Okay. Is that it? Are we done? Do we have a game? Hell yeah. Get our money up. Buy a ranger to take care of this one. Oh, let's place a couple more of these. Seems sensible. Yeah, it's shooting, it's doing its thing. What happens if I place this like right there? Okay, yeah, it causes it to kind of snap back, which is what we'd hoped for. Interesting how the health goes below 0 when it's dying. I don't really know what's happening there. It makes sense, right? I've also unfortunately duplicated this code in all of my hero classes, which is shameful, and I am truly ashamed of myself for doing so, but you know, we've just hacked this together in a few hours, so I will ultimately one day forgive myself. Okay, let's clear out the board initially so we don't have these things preset. no longer need our test things. Just set up the waves. And now let's just try and play through this, and we can maybe tweak the numbers slightly to make this somewhat balanced. Should probably get a spreadsheet out and figure this out properly, but okay, something weird happened there, which is that I believe something's happening with like a scale function getting called, or something with the matrices. We create these with the push and pop matrix stuff is not happening as we might expect, maybe. What's happening here? Push matrix, pop matrix. We do it like a scale. Oh no, it's image mode, right? We're not setting image mode to center, which we should definitely do from the get-go. Okay. Got no choice but to place a couple of these down at the beginning. Oh, we're not taking any money away when we spawn stuff. Let's fix that. Quick snap. Okay. Price equal price equal. Okay. Drop our dude down. Okay. Probably shouldn't put him in the lane with the enemy. Now we need to wait. There's something which can stop these dudes. This feels like Plants vs Zombies already a little bit. Do I place more? Yeah, let's take a risk. I may have made a bad decision. Okay, let's put these in as like a last line of defense, maybe. I should probably have left more room to build more money generators. Ah! Are we going to make it through this first wave? Okay, we're taking a couple hits, but I think our warriors can manage this easily enough. Maybe we just let them clear out this wave and then build a couple of ranges for the next one. Nice. Okay. Yeah, the ranges are blatantly too powerful. That's the first thing I've noticed. That felt alright, like, right? For the first wave, I took a bit of damage, I made a bit of money. Could just about afford to place some ranges down. That feels like a good kind of flow there. So maybe I will drop the damage output of the ranger, and I will introduce a faster variant of the zombie, perhaps. Yeah, these rangers are smashing it. On the other hand, adding a couple more faster zombies might... You know, they're getting relatively close. There's also some RNG in terms of how these stack up in the lanes. Like, you could improve our spawner, or change our spawner at least. Debatable whether it's an improvement to have a fixed number of enemies coming through each lane, and then maybe still be randomized, but ultimately end up distributing those fairly through the lanes. Okay, so I think I will drop the damage amount to like... So right now they're taking out these basic things in like 2 shots, right? Or 4 shots. So if I did like 3, it would have a relatively significant amount. Okay. So I now want another kind of walker which has maybe different health and different speed. So I think I will make this not like a constant. Instead, something like this, right? So I can pass in I can kind of parameterize this actual type of enemy. And then in the spawner, I can say I'm going to spawn this in with a particular speed, which is like 0.1 F and 20. Is that right? Other way around. Okay. Which means I can now introduce like a fast walker without having a whole new copy paste of that class. So let's add that code. Okay. Add a fast walker, and they're gonna have maybe still 20 health, but like maybe 1.3, so they're gonna be pretty rapid. And then I guess another one that makes sense is like a kind of bullet sponge, right? And I think maybe we can... I was going to say we can make the sprite bigger, but that's actually going to be a pain to implement, so... you know what? Okay, maybe this is fine for now. Let's change our spawning. Let's add some fast walkers in here. Like maybe like 5 of those. And then in the final wave, like 15. See how this escalation feels. Okay, I think I'll play through this and then maybe we'll call the stream a day after this. We've made something which we can reasonably describe as a game now, I think. Kind of pleased with how this has turned out. Okay, let's go. Oh, get up, guys, down ASAP, right? Start generating money as quickly as possible. Okay, they're stacking up in those top lanes, so I can kind of focus stuff there. I'm going to try and leave a gap for more things to sit in the back row. No, let's not do that now. I need my warrior in place. There we go. Oof. Hurry up. Okay. Now I've got a little bit of time, I can maybe afford to place another one. This really feels like Plants vs Zombies, if I'm honest. Like the logic I'm going through, like the kind of gameplay thoughts going on here. Another there. Okay, we're doing alright. We got kind of lucky that we have an empty lane. Definitely should place more. Okay. I feel like maybe I should have moved them forward to have the ranger behind them. Okay, I think what I'm going to do is place one more of these and wait to see where they start spawning to then place my ranged attacker. Okay, boom. And boom. Boy, are they fast, and they all seem to have spawned at the same time. Yep, I should have put these in the opposite positions, I feel. Definite screw up there, because my range is getting destroyed. Okay. So, I put you in front. And then you in there. Feels like a better setup. Same here. Ah! Getting overwhelmed. I need to kind of watch now for these getting taken out. That's gonna happen, right? No! Okay, go. I think my second line's gonna do okay. Yeah, range is way weaker now we have these faster enemies, it seems. Just gonna let them get chewed up so I can try and place a ranger down. So I think in Plants vs Zombies you could dig things up, dig up your plants and replace them if you wanted. I don't know why I expected that to work, that I could replace that, because I didn't implement that feature. Like, why would it just work? I've got loads of money, I should probably just build stuff. See, I know one of those streams has gone okay when I'm actually genuinely just playing the game at the end of it, which is what's happening now. So I think we're in a good spot. I kind of want them to be killed so I can put the ranger back. Oh, quickly drop another one in there. So, ranger to die probably. Yeah, that was kind of dumb. You know, if these break through, then it's game over. I just need to replace one quickly enough. No, I'm dead. I've lost. But it came down to the final zombie. There we go, look at him. I've got no... Oh, actually, I think I could place one of these super quick. If his death animation is quick enough for me to then place one down before the zombie like moves through. No. Game over. Ooh, game over twice. Interesting. Well, I'm pretty pleased with that. Like, that was actually a playable game. Like, you could tweak that, you could add more types, enemy types, hero types, tweak the spawning logic maybe. There are kind of a couple quality of life things as well. Around being able to like replace heroes and things like that. Plants vs Zombies also had like single-use items, which are kind of cool. But as a first pass or something like this, I'm actually pretty happy with how this turned out. So I think I will leave it at that. I will hopefully post the VOD along with the source code sooner rather than later, so if you want to noodle around with this, you can play around and maybe tweak some of those parameters and add some new enemy types and things yourselves. Otherwise, I will catch you next week. Okay, take care everyone, bye bye.